This one has large numbers, but we don't have to worry about the large numbers. We will do it exactly the same way as we did the last one. First thing we always want to do when we are completing the square is to move over the constant term to the other side. We will subtract 71. And now we have our x squared terms, or our x terms, sorry, on one side and number on the other. Now the same thing happens as last time. We wanted to make whatever is in front of our x squared term, we want that to be a 1, a positive 1. If it's not 1, then I need to divide by exactly what's sitting in front of my x squared term. Now we will reduce our fractions. 27 divided by itself is 1. It's a positive 1x squared, which is exactly what I wanted, minus, now I can reduce this fraction 90 over 27. What is common, the largest common factor between 90 and 27? Hopefully you thought of 9. 9 goes into 90 10 times. 9 goes into 27 3 times. Now we have our reduced fraction. Always reduce as much as you can along the way to keep things smaller. Now we want to complete the square. Same thing as last time, we will take half of that linear coefficient, which means that we are going to multiply that by 1/2. And once again, we want to reduce as we go. If I multiply negative 10 over 3 by 1/2 to half it, we see that we have common factor of 2 in the top and the bottom. So we will get negative 5 over 3 as the half. After I half it, then we know that we are going to square it. So we get positive 25 over 9. What do I do with that? Well, what we wanted to do was to add that to both sides of our equation to create that perfect square trinomial. So we're going to put in 25 over 9 on both sides of my equation. Leave ourselves a little bit of room there so we can put in our 25 over 9. Now we do have fractions again that we need to combine. What is the LCD of 27 and 9? Well, that would be 27. So I'm going to multiply the top and the bottom of my second equation by 3. We get negative 71 over 27 plus 75 over 21, which gives me my constant of positive 4 over 27. So we've completed our perfect square trinomial, and now we want to actually factor that. Remember that when I go to factor this perfect square trinomial, we already know how it factors. It factors as a binomial squared. Put the variable inside, and where is the half that we took? It's right here. We always include the half that we took, including the sign. We took half of negative 10 over 3, which was negative, so inside will go in negative 5 over 3. Equals our constant 4 over 27. Now we are all set to take the square root of both sides and simplify our answers. I'm going to take the square root of both sides. We end up with x minus 5 over 3 equals plus or minus. Now we can start to simplify our square root of 4 over 27. Let's take the square root of the top and the bottom separately. And let's start to simplify this. We know that the square root of 4 is 2. What about the square root of 27? It's not a perfect square, but we do know that 27 is made up of 3 times 3 times 3. We talked about a couple different ways that we can simplify, but if we break it up as 3 times 3 times 3, we should see that we could take out 2 of a kind and bring that out to the front. So that would be 3 outside, square root of 3 stays in. Now, is this rationalized? We don't want to leave a radical in our denominator, so let us rationalize. We're going to multiply by exactly the square root that is in our denominator. We can do that because we only have one term in our denominator, so that'll take care of it. 2 times the square root of 3 divided by 3 times the square root of 3 turns out to be the square root of 9. You can see that we're getting good practice working with our radicals here and simplifying. 2 times the square root of 3, and we know that the square root of 9 is 3, so now on the bottom we have a 9. So we simplified the square root of 4 over 27, and the simplified form of that is right here. You have to do a couple of things there, but it's good practice. Now when I go to solve my equation, we have x minus 5 over 3 is equal to plus or minus our simplified form 2 square root of 3 divided by 9. Now I would ask myself, do I need to separate in 2 separate equations to deal with the plus or minus? This one has a radical, square root of 3, and the 5 over 3, when I add it to both sides, does not have a radical. So these are not like terms, so I can add 5 over 3 to both sides of my equation and just tuck that 5 over 3 right in front of my plus or minus. So our final answer here, x is equal to positive 5 over 3 plus or minus 2 times the square root of 3 all over 9.